everyone, I am Indah Purnamasari and I am a student of Chemical Engineering Department at Semarang State University in Central Java. Here I am as Assistant Research of Dr. Ratna Dewi Kusumaningtyas will explain about the advance in biodiesel process and technology. The current issues on environmental pollution and the decreasing of fossil fuel sources have promoted the concern on the development of finding the alternative energy sources. Among the available alternative energy sources, biodiesel has attracted great attention worldwide during past few years as renewable, biodegradable, and non-toxic alternative fuel. Biodiesel production process and technology has been developed from the first generation to the second generation and from the laboratory scale to the commercial scale production. Biodiesel is usually defined as a mixture of monoalkyl ester from vegetable oil and animal fat, which can be used as alternative for diesel engine and combustion ignition engine. In Indonesia, biodiesel has to fulfill the specification which refer to American standard and European standard, and the specification of properties of biodiesel is shown in the table 1.
From the table 1, the most important point of properties of biodiesel are ester content, density, and viscosity. We can see that the ester content refers to European standard has minimal value about 96.5 and the density refers to European standard has value about 860 until 900. And for viscosity refers to American standard has value about 1.9 until 6 and refers to European standard has value about 3.5 until 5.
Overall advantage. For example, it has better lubricant than diesel fuel, and it has higher flash point, thus it offers safety in handling, storage, and utilization. Besides that, biodiesel releases lower pollutant and can be combusted completely. Biodiesel can be produced from vegetable oil or animal feedstock. First generation, biodiesel is produced from edible and high quality vegetable oil such as crude palm oil, soybean oil, and sunflower oil. This situation leads to the problem between fuel and food conflict. To avoid the conflict between food and energy, non-edible oils should replace edible oil raw material biodiesel production. Some promising non-edible oil production feedstock, which are abundant in Indonesia, such as jatropha curcas oil, cotton seed oil, nyamplung seed oil, and waste cooking oil. Vegetable oil cannot be directly applied as a diesel fuel since it commonly contains some impurities, for example, free fatty acid, phospholipid, water, odorant, etc. Vegetable oil also has high viscosity, which can cause damage in vehicle engine. The high viscosity of vegetable oil will cause problem in direct injection engine. For example, fuel atomization doesn't occur properly, so it can cause deposit carbon, oil ring sticking, and lubricating problem. Therefore, the vegetable oil should be converted into lower viscosity fuel through some method such as microemulsion process, pyrolysis, and transesterification. Transesterification is a commonly process used for biodiesel production due to simple and low-cost production.
Transesterification reaction is a sequence of 3 consecutive and reversible reactions in which N monoglycerides are formed as intermediate, yielding one ester molecule in each step. As we can see in the picture, the stoichiometric reaction requires 1 mole of a 3-glyceride and 3 moles of the alcohol. This reaction is an equilibrium-limited reaction, hence excess amount of alcohol is usually used to increase the yield of the alkyl ester by shifting the equilibrium toward the formation of biodiesel, and to allow its fast separation from the glycerol formed as a byproduct. The optimal process is only obtained by using an excess reactant, with the molar ratio of oil to methanol is 1:6.
Trans-esterification reaction is simple and effective for enhancing biodiesel synthesis, but this process is only appropriate for high-quality feedstock. For low-cost biodiesel raw materials such as non-edible oil and waste cooking oil, which usually contain high free fatty acids, a pre-treatment process using esterification reaction process should be applied. Esterification of free fatty acid usually need a far excess of alcohol, with the molar ratio of free fatty acid to alcohol is 1 to 15 until 1 to 60. In esterification reaction, 1 mole of 3-glyceride react with 1 mole of alcohol and yielding 1 mole of methyl ester or biodiesel and 1 mole of water.
Both trans-esterification and esterification reaction faces a problem regarding to the side product separation, namely glycerol and water. An alternative route to avoid the formation of glycerol or water side product is by synthesizing biodiesel via interesterification reaction. This process using methyl or ethyl acetate as reactant instead of short-chain alcohol. Chemical interesterification of oil with methyl or ethyl acetate will result in methyl ester or biodiesel and triacetylene, whereas glycerol would not be produced in this reaction. Triacetylene is well known as fuel bioadditive, which can increase fuel quality in terms of viscosity, oxidation stability, and cloud flow properties such as cloud point and power point.
Several new and advanced progress in biodiesel production and technology are continuous stirred-tank reactor, ultrasound irradiation, microwave technology, reactive distillation, membrane technology, and supercritical technology. Conventional batch process of biodiesel production needs a series of separation steps which make it costly. Therefore, process intensification is important to develop a more efficient and economical process.
Reactive distillation is known as second-generation process which combines distillation and reaction in a single column, which is divided into reaction, rectifying, and stripping section. In this process, reaction and separation occur simultaneously. Reactive distillation is a promising alternative process for equilibrium-limited reactions such as biodiesel production via trans-esterification, interesterification, and esterification routes. It is due to the fact that the continuous removal of one product will shift the equilibrium to the product formation. Besides, this integration could reduce separation steps, lower capital and operating costs, and shift the equilibrium toward to the product. Microwave irradiation is the electromagnetic irradiation with frequency range of 0.3 until 300 GHz. They lie in the electromagnetic spectrum between infrared wave and radio wave with wavelength between 0.01 and 1 meter. When this technology is applied for trans-esterification reaction, the microwave interaction with the reaction compound will result in large reduction of activation energy due to the increased dipolar polarization phenomenon. This causes the higher reaction rate will result in the higher reaction conversion and biodiesel yield. It is shown that microwave irradiation is a fast and energy-saving method compared to the conventional trans-esterification method for biodiesel production. By using microwave technology, biodiesel with 99% conversion can be achieved at 7-minute reaction time. Ultrasound irradiation is an attractive novel technology for improving biodiesel trans-esterification. The role of ultrasonic in chemical reaction is the formation and collapse of microbubble and release of high energy locally in the stock waveform. Due to the increasing the local temperature and pressure, molecules are induced to generate high reactive radical species, which drive to the product formation. The ultrasound system enhances mass transfer rate, which results in the reduced reaction time, higher product, and lower production costs. Membrane technology is also another interesting choice. Membrane reactor is designed in two phases, and the first phase is membrane reactor to convert oil into biodiesel, and the second one is separative membrane to separate product from impurities such as side product, soap and the remaining reactant. This process can simplify the reaction and separation in single units as well as drive the reaction toward the product formation. Membrane unit can be made of organic, inorganic, or combination material. Inorganic materials such as metallic, solid-based, and carbon-based membrane are favorable since they resist in an extreme condition. Membrane is efficient and has potential to be a breakthrough technology. Supercritical technology is recognized as clean technology for biodiesel production. Supercritical process is the process which is conducted in the presence of supercritical fluid. Supercritical fluid can be stated as substance at the condition which is higher than its critical temperature and pressure. Under this condition, supercritical fluid behaves as an intermediate between gas and liquid as their density. Among the popular supercritical fluid is supercritical carbon dioxide. By conducting transesterification and esterification reaction in the supercritical carbon dioxide, triglyceride and free fatty acid will form a homogeneous mixture with alcohol. This will break the mass transfer resistance. Besides, at the high temperature and pressure, the reaction rate increases rapidly. The combination of high mass transfer and reaction rate will result in the high conversion although no catalyst is added to the reaction system. This makes supercritical fluid process is called as a clean technology.